Hi everyone, welcome to lesson 2. Today is radian measure. This is lesson 2 of trigonometry. So, what is radian? So it says here radian is the measure of an angle subtended um, at the center of a circle by an arc equal in length to the radius of the circle. So basically, what does that mean? Um, we're looking for this little section right here. So subtended means we're measuring this little section from this angle here. And so 1 radian is going to be the measure of this section. One full rotation through a circle is considered 2 pi, which takes us through 360 degrees. So we can say 2 pi is equal to 360 degrees. So I'm going to quickly jot that down. So 2 pi radians, is equal to 360 degrees. Therefore, 1 degree, if I was looking for 1 degree, it's pi over 180 rads or radians. 1 radian is the same thing as saying 180 degrees over pi. We can say 1 radian is approximately 57 degrees, but usually we're going to use this conversion factor right here. We're going to use this pi over 180 to get from degrees into radians, or from radians back into degrees, you're just going to go 180 over pi. So again, here's your quick note. To convert from radians to degrees and from degrees to radian, we're going to take degrees to radian, whatever you need to multiply by here, whatever your degrees is, multiply by this pi over 180, reduce that fraction there, and most likely you'll get your answer in terms of pi. And vice versa here, if you were in radians and you wanted to get it into degrees. So again, on this side, you take your degrees, you multiply, you get radian over here, and over here you'd start off with radian, multiply by this factor, and you get your answer in terms of degrees. In example 1, we're going to start to convert the following to radians as exact values. Exact values means no decimals, here. Then round to the nearest hundredth. Then we will rewrite our answer in terms of decimals. So if you get 45 degrees, I'm going to take my 45 and I simply just multiply by my factor of pi over 180. So if a quick trick here, if I have my degrees up in my numerator, your 180 has to always be in your denominator. I'm going to quickly multiply these two together using my graphing calculator here, and in this case here I'm not going to use pi. I'm going to leave pi as is, but I'm going to go 45 times 1 divided by 180. 180, there we go, and enter. Got me a small decimal. If you're not sure how to convert it, you're going to go math frac to get it back into a fraction. There we go, we got 1 over 4. So here back in our question, 45 over 180 is the same thing as 1 over 4, so I'm going to leave my 4 in my denominator there. That pi, again, we haven't touched, so I'm going to leave it in my numerator. This is exact values. Exact values usually has a pi in your answer. To convert this into decimals, all we simply do is type this in, pi divided by 4, and we're going to go to 2 decimals because it asked us to go to the nearest hundredth, so 2 decimals is the nearest hundredth, so we're 0.79. Same thing over here, in negative 115, we're going to multiply it by the same factor of pi over 180, and again, don't forget your low degree sign. And again, we're going straight to our calculator to try to reduce this fraction. So I'm going to go negative 115 over 180. And right away, instead of going into a decimal, I'm just going to go math frac right away. That gets us negative 23/36. So we have negative 23 over 36 pi. And this, of course, is equal to, and if you wanted to evaluate that, so I'm going to just type in negative 23 pi divided by 36. Into the 2 decimals, I'm 2.01, negative 2.01. 240, let's do 240, so we're going to go multiply by pi over 180. And again, straight to my calculator, if I have 240 over 180 there, math frac, that's 4 over 3. So back in our answer, you'd have 4 pi over 3. And again, you wanted to rewrite this in terms of decimals. So that's what I'm typing in, 4 pi divided by 3 on my calculator here. To 2 decimals, that's 4.19. Last but not least, 600, and again, it's the same multiplying factor, pi over 180. And let's see what we get. So again, 600 is going to be divided by 180. Go math frac. There you go, 10 over 3. So our answer here will be 10 over 3. And don't forget, pi is right beside 10 there. And again, if we want to convert this into decimals, I'm going to go 10 pi divided by 3. We get 10.47. And there we go. And the one thing I forgot with all these decimals is my units on them. Rad, R-A-D, will represent radian. In terms of pi, if you have pi in your answer, that's already exact values of radian, so you don't really necessarily need to write rad next to it. Over here in example 2, we're going to go in the opposite direction, where you're going to convert from radians back into degrees. So for all of these, I'm going to multiply by 180 degrees up top with pi in my denominator. The reason why pi is in my denominator, it's going to cancel out with that numerator pi, leaving you with only degrees as a unit left over. So here we go, to the nearest degree. So I'm going to go 2 pi over 3 on my calculator, multiplied by that 180 over pi. There we go. If you hit enter, that's going to get you your answer, 120 degrees, and we should be good. Don't forget your degree symbol. Over here, we're going to multiply by the same thing, so multiplied by 180 over pi. So this gets me here, negative 225 degrees. 3.42, and again, because there's no pi symbol in it, you're going to denote it with rad, R-A-D. You're going to multiply it still by the same factor of 180 over pi, and you're left with an answer in terms of degrees. This should be 196 degrees rounded. Negative 6.03 rads, again, radian for short. There we go, multiplied, and again, you're going negative 6.03 times 180 divided by pi. This is going to get you to the nearest is negative 345 degrees. There we go. In example 3, it says draw the following angles in standard position. Standard position again meaning starting from your x positive axis, and state the reference angle for each. So if you're looking for pi over 3, the way that we're going to do this is I'm going to convert this into degrees to see what this is, because I know what my degrees are. So it's 0, 90, 180, 270, and all the way back here would be 360. So let's get this into in terms of degrees. So if I had pi over 3, I'm going to multiply that by 180 over pi. That leaves me with 60 degrees. So I'm trying to sketch on 60 degrees onto my graph here. And so again, starting initial arm is on x positive 60 degrees. Well, if you started around down here, that's about 30. Halfway up is about 45, so 60 is about 2/3 of the way up. And there you go. That'd be about 60 degrees. It says here to draw your angles, draw the following angles, which we've drawn. You should also label it. So between here and here, your initial to here, this is pi over 3. And again, that's in terms of radian, which is equal to 60 degrees. So now you have both conversions on there. So here we end off in quadrant 1. I is in quadrant 1. And my reference angle, because reference angles are always between 0, theta is your angle, and 90. So between 0 and 90, not including 0 and 90, that's your reference angle. So my reference angle here is only 60 degrees there. And reminder, reference angle has to be towards the x-axis only. Okay, so draw a line straight down. What's that angle there to the x-axis? In the next example here, we got 2.34 rads. Let's convert that over. So 2.34, and again, same multiplication factor, 180 over pi. 134 degrees, and that's our best that we're going to try to get to, so 134 degrees. And again, where's 134? So again, if you had 0 degrees here, right here would be 90. Here's 180. 270 is right here. So then here, if you got back here, this is now 360 degrees. So we're probably in quadrant 2 because we're 135, or sorry, 134. So if I'm here 90, 90 plus what would get me to 134, or you can go 180 minus 134 and that'll get you the difference as well, however you want to find it. So I'm going to go 134 minus 90. I can do it this way here. So I'm 44 more degrees, so 44 degrees looks like something like this. It's close to 45, so it's basically splitting this almost right down the middle there. Okay, so let's draw on our standard angle. So from my x-axis all the way around, that's going to be my 2.34 rads, which is also equivalent to 134 degrees. And in this case here, we want to find our reference angle. Our reference angle is going to be right here in green here, and that's going to be my reference angle, and that's the angle I want to find. If I'm already 134 degrees going in the positive direction, my reference angle to get to 180, and again, we already did it right here. Oh, wait, no, we haven't. So if I go 180 minus 134, that's going to get me a reference angle 46 degrees. So my reference angle 46 degrees right in there. So let's fill out some of this here. So we're in quadrant 2, and our reference angle again, how did we do this? We can do 180 minus that 134 equals 46 degrees. So our reference here has to be 46 degrees, and that's it. If you wanted to write this in terms of radian, you definitely could have as well. All you had to do is simply convert it back, and you'd get something in the ballpark of 0.80 radians. And over here, of course, my reference angle, if I was 60, I can also convert that back. 60 is the same thing as saying pi over 3. In example C, again, what I'm going to do is convert it from radians back into degrees and then sketch it on. So this here is the same thing as saying, so if you had 5 pi over 6, that's going to be the same thing. So we're going to multiply by our 180 over pi factor. There we go. 150 degrees. And where would 150 be? So again, starting from our initial, so this would be 0, 90 would be right up here, 180 is completely flat, so 150 we're probably just right around here because we're about short 30 more degrees until we get to 180 there. So we have, that didn't work. Let's try drawing it on instead. So from here to here is 5 pi over 6, which is 150 degrees. And again, our reference angle is going to be towards our x-axis, so it's this angle right here. This here is my reference. We are 30 degrees because 30 plus 150 is going to get us to that 180. So which quadrant are we in? We're in quadrant 2, and our reference angle here, if it's 30 degrees, again 30 degrees, I want to convert that over, that's pi over 6. Last but not least here, we're looking for negative 13 pi over 12. Again, I want to convert that in terms of degrees, so I'm going to go negative 13 pi over 12 multiplied by the 180 over pi. So that's about negative 195 degrees. And so again, let's try our best to draw that on. So again, reminder, if we're going negative, you're going to go in the clockwise direction. So this here where my arrow is, this is going to be 0, this is 90, 180, 270 is going to be here, and this is negative 270 this time, by the way. So between 180 and negative 270, negative 195, we're probably right over here as well. Okay, let's label that in. So to get to negative 195, we went in the clockwise direction right there. So this is negative 195 degrees, which in standard position, what are we? In standard, Usually we are going to go clockwise, but let's find the coterminal to this one. So if we went 195 negative, that's the same thing as going 360 minus 195. It's the same thing as going 165 positive. And so here we still want to find that reference angle. So if we're at 165 positive, how much more until you get to 180? You can simply go 180 minus 165. There you go, just 15. Or you could have gone 195 minus 180, which would have gotten you to 15 as well. So my reference angle here has to be 15 degrees. There you go. So again, we're ending up in quadrant 2, and our reference angle here, 15 degrees, which if we convert it over, it's going to be pi over 12 radian. So that's a pi divided by 12. Coterminal. So just like lesson 1, we're going to find if these are coterminal. How do you find coterminal? Well, if you want to convert them all into degrees and then work with it in terms of degrees, that would work. It'd actually work out a bit faster. So that's what I'm going to do here. So I'm going to take my pi over 3, which is 60 degrees, and I'm going to compare that to negative 5 pi over 3, which is negative 300 degrees. And you want to find out if these are coterminal. So how do we do that? Again, coterminal is take your principal angle and add 360 to it. Or you can take that principal, and 420 is way too much, and we're looking for a negative answer, by the way, so I'm going to go take my principal angle minus 360 from it, negative 300, so therefore 60 and negative 300 are coterminal, and these two are in fact coterminal, so therefore coterminal. And again, what did we do? Well, we quickly tested by going 60 minus 360. That equals 300, or sorry, negative 300 degrees, and therefore they are coterminal. Over here, let's convert both of these. So 25 pi over 18 is the same thing as saying 250 degrees, and 10 over 3 pi, so 10 pi over 3 is the same thing as saying 600 degrees. So again, you're trying to take one of these two and add either 360 or subtract 360 from it. So I'm going to start with my 250 and let's test. So if you start off with 250 and to get to 600 I'm going to add. So if I add 360, I'm up to 610. So we are well past our 600, so therefore not coterminal. Over here, again, we want to convert it, so the first thing I do is convert. So this first one is going to be negative 60 degrees. 5 pi over 3 is positive 300 degrees. And again, let's do our quick check. So if I start off with, again, it doesn't matter which one you start off with. I'm going to go with the negative 60 degrees. I'm going to add 360 to it and see what happens. Well, if you add 360 to negative 60, of course, that's going to get us to 300 degrees. Therefore, this last one here is coterminal. In example 5, it says find two coterminal angles to the following and state the general form. So again, if you had negative 2 pi over 3, to do this in terms of radian, instead of converting it this time, to do this in terms of radian, I'm going to, and if anyone remembers from page 1, add and subtract 2 pi, because 2 pi is the same thing as saying 360 degrees. So again, I'm just going to write a quick note here. Let's write it off to the side here. 2 pi is the same thing as saying 360 degrees. So if we wanted to do this in terms of radian this time, let's use our calculator. So on my calculator, I'm going to do the following. Negative 2 pi over 3, and in the first one, I'm going to add 2 pi. And then in another one, I'm going to go 2 pi divided by 3, and in the second version, I'm going to minus 2 pi. Going to figure out what these are in terms of fractions, and let's see what we get. So this is the same thing as saying negative 2 over 3. Don't worry about the pi's, because our answer will be in terms of pi's anyways, plus 2. You got a decimal. Again, we don't deal with decimals, so convert that to a fraction. So you have 4 over 3 pi. There you go, 4/3 pi. Down here, if you had, again, the same question, so negative 2 over 3 this time, but instead of adding like previously, we're going to subtract. Math frac right away, negative 8 over 3. So I'm going to write negative 8 over 3 pi right there in your numerator. And so these two are going to be coterminal to negative 2 pi over 3. And to write our general statement or general form, you always want to start off with your principal angle. So out of these three angles, my principal is right here. So my principal is going to be 4 pi over 3. And we're going to go plus 2 pi, which is 360. And we're going to add on the letter n because we don't know how many 360s we want to add. So n has to be an element of an integer. In the second example here, again, we're going to do something similar. So we got negative 5 pi over 12. And in this case, again, we're going to add 2 pi. And we're going to do another case here, 5 pi over 12. And in this case here, we're going to minus 2 pi. And again, we're just going to reduce each of these fractions to see what we get. So in the first one, negative 5 over 12. And again, don't worry about the pi's when you're trying to convert these. So don't worry about the pi's for now. Plus 2. Math frac 19/12. Same question here, but this time we're going to subtract negative 29/12. So there we go. So we have 19/12 and negative 29/12. And again, both of these are missing pi next to them, so I'm going to add pi right here and pi right here. There you go. And to write this in terms of general form, again, we got to use our principal angle. So principal angle is going to be the first positive that we see. So it's going to be 19 pi over 12 plus 2 pi n, where n is an element of an integer. In our last example here, 8 over 3 pi's. So what do we have? So here again we're doing the same, so I'm going to go 8 pi over 3 plus 2 pi, then 8 pi over 3 minus 2 pi. And again, straight to my calculator to see what these are fractions wise. So the first one here, if you're adding, you should be around over 3, that's 14 pi over 3. And here if you're subtracting, that's going to be 2 pi over 3 left over. So principal angle wise, I usually am going to use my smallest one here to write my general form. So I got 2 pi over 3 plus 2 pi n, where n is an element of an integer.